My name's Stephen Cooper. I'm with Juniper, and I'm going to not only talk about rethinking your Wi-Fi designs, but actually more about how you should be doing HDE designs or high-density designs with Wi-Fi 7 APs. Now, Wes was talking earlier about there's so many more things that we could improve instead of focusing on the new and improved features, supposedly, of Wi-Fi 7. I'm going to talk about design fundamentals. Now, we've all seen some of these challenges out there with trying to balance high-density deployments with the number of APs, how close they are placed together, and also trying to do the new way of doing capacity-based designs. And there's a lot of over-engineering that happens, and there's also a lot of under-engineering that happens as well. We're sometimes the victims of our own software and tools that we use without the proper knowledge, without the proper training, and even sometimes, we just fall victim to someone, excited salesperson has just sold too many APs to a customer, and they've deployed them all up, and they're wondering why things aren't working too well. So, without naming and shaming, but I've had some customer conversations where they're looking at the dashboard, they've deployed their wireless, they're like, why is my roaming SLE so terrible? I'm seeing sticky clients, I'm seeing suboptimal roams and mist. Why is my capacity terrible? I'm seeing co-channel interference just drop off the cliff, and I'm just having problems here and I can't quite figure it out. So I jump on a call with them, we jump in, have a look at the dashboard, and I'm like, is your scale correct on your floor plan? Yeah, the scale's correct. Your APs are 5 meters apart. What are you thinking? That's never going to work. And so, we go through this exercise of educating these customers as to why that's not going to work so well, encourage them to actually disable about 50% of those radios to actually get the Wi-Fi performing as it should do. So, the old rules of thumb may no longer apply when you're talking about designing for high density and high capacity and trying to get the best improvements out of future generations of Wi-Fi, not just Wi-Fi 7, but definitely taking advantage of 5 and 6 gigahertz in future. And there are challenges with external antenna deployments. A lot of the designs and deployments that we've done in the past around really complex RF environment and high density requirements, whether it's large public venues and stadiums, or even just controlling the RF in a warehouse and distribution center, comes with the added cost and complexity of installing external antennas correctly. And now when done properly, it's perfect. Everything works really, really well, but there is a lot of challenges with that too. And sometimes we are the victims of cost and time and effort, and some people just skip the difficulty and incorrectly deploy the wrong AP with the wrong antenna radiation pattern in the wrong use case, and again, wonder why it does not work so well. So just a quick example of how co-channel interference can be exacerbated by APs being too close together. You've probably seen and lived this in your own careers as you've done designs and post-validation surveys or even just monitoring live deployments. So this is, APs spaced about 8 to 9 meters apart in an office environment, and I've had a very similar customer have that same challenge where they've actually inherited this design from someone else. It's been a third party that's done that design, and they've taken over the monitoring and management of this network, wondering why things are not going so well. Likewise, we've had the same scenario where someone has just said, save time, there's no time to do a redesign, let's just do a rip and replace of the existing deployment. And then nothing's been optimized, nothing's been improved, and you end up with a mess. So this is 5 gigahertz co-channel interference with 12 APs, and I'll give you an example of how we can improve that a little bit later on. And going back to this roaming scenario with sticky clients and suboptimal roams, with clients doing interband roams and maybe changing from 5 to 2.4 when we really don't want them to, nice little view of a moonwalking Harmona roaming man going backwards across an office environment. You can see how sticky that client is when you've got omnidirectional APs placed on the ceiling too close together. And we're even just talking about a nominal, quite low transmit power here too. We're not talking about anything excessive here, but you can see that their experience has been terrible, their data rate has dropped down, and they've not roamed to any of those newer neighboring candidate APs that could have been utilized in that example. Now, when we talk about, exactly what Wes was mentioning earlier about we have new options now for designing and deploying high-density Wi-Fi. We've proven this in the field, not only in the large public venue and warehouse and distribution center use cases, but even in high-density office environments. So even if you're just talking about normal office environments that are using Teams and Zoom and a lot of application traffic, but especially when you're talking about CAD designers, application developers, people that are using a lot of high bandwidth applications and consistent throughput as well, sustained throughput on the network. We've proven this with comparing, for example, a AP AP45 on the right-hand side. Sorry, my pointer's not working. Just an omnidirectional AP45 on the right-hand side compared to an AP45E with an external directional antenna doing 5 gigahertz and 6 gigahertz. We've shown that we've seen a big improvement in terms of not only roaming capability, but sustained data rates in that environment as well. And so that's the use case as to why do we do integrated directional antenna access points. And so Wes and the team have done a fantastic job at designing some of these, and we're not the only ones doing this these days. There's a lot more options out there as well that you can look at. But we've certainly seen the benefits of this, not only from an ease of deployment, but in terms of finding that balancing act between not having your APs too close together and having them too far apart with too high transmit power, reducing suboptimal roams, reducing the sticky client problem, even improving scenarios where we've seen the hidden known problem occur in high-density environments, because you've got that better signal control. So instead of blasting out in a donut shape across an entire floor, even with a very low transmit power, you're doing a nice little tight cone of RF coverage in these sections where you've got rows and rows of workstations, even in the meeting rooms as well. You're going to see a lot better signal control there. And when you actually look at doing your designs and validation of these deployments, you'll see that your primary and secondary coverage is still as good, if not better than before. So we're not compromising anything in terms of coverage, and we're not necessarily needing any more APs than before. Yes, as you're reviewing from generation to generation, your 5 and 6 gigahertz designs might dictate slightly higher density than before, but that's to be expected as the Wi-Fi has become more of a commodity and a necessity in the environment. But the other good thing with this better roaming and predictability, we're getting less stationary clients roaming ad hoc. You shouldn't be expecting your clients to roam when they're just sitting on the desk like you are right now. And when they do roam, we're seeing a higher maintained data rate and MCS rate. So the consistency of that application usage, maybe it's a live team or Zoom's call, is that person who's roaming is better and more consistent too. Not only that, you're reducing your own internal co-channel interference, you're reducing any impact from any external co-channel interference as well, and it makes it easier to design and deploy these into lots of high-density environments, not just offices, but university lecture theatres and auditoriums, even some retail environments, and even possibly some warehousing environments, depending on the complexities and heights and layouts of those particular environments. And the other cool thing that we can do is also do this with outdoor APs that can be rated for both outdoor channel use and indoor channel use, giving a flexibility in deployment as to what you want to do here. So we've actually got a software-defined radio that can do 3 different radiation patterns. The default is very similar to most of our other outdoor access points. It's a 90 by 90 pattern. You'd mount that on the side of a wall to provide some outdoor coverage to a park or a parking garage or just outdoor areas in a university campus, and that's your typical default mode of operation for that. But you could use the same access point, software define it to say, we want to do a slightly tighter beam width, 90 by 30, and that could actually be used in your warehouse high racking. It's got a very tight rectangle shaped pattern. It could be used in cold rooms. It could be used anywhere that you want to provide coverage down a specific hallway. And it means that you've got this balance now of controlled RF coverage, but also simplicity to install and reduce cost. Plus it's weatherized as well. So you've got that weatherized element too, whether you want to use it in cold stores or refrigerated rooms, and you've got that flexibility too. Lastly, we have a 30 by 30 pattern, and then we can actually get that nighttime type beam width if we're going to be doing like a point-to-point link. So we have this ruggedized AP66D, directional. It can be used indoors or outdoors. We don't need to do any other additional weatherization. 36M, 47D, and they can do those directional patterns. And so with 47Ds deployed indoors, 10 APs, so 2 less than 12, we can then actually see that we've improved the same radio configuration, better co-channel interference, and so we have a better noise floor overall with that. And from a roaming perspective, with the directional pattern on the ceiling, we're going to see a smoother roaming experience in this environment and actually properly utilize those access points, and that client will have a smoother roaming experience throughout that environment too. And you'll see we get a nice happy walrus at the end of this. So you've got to validate this in your own environment and see what suits, but the summary is reconsider what you're doing. The old rules of thumb may no longer apply. Your actual placements may need to be adjusted for what you're doing for new Wi-Fi 7 and high-density designs. Make sure that you're using the right AP and the right antenna for the job, because while this is awesome, It's not going to suit every single use case, but it gives you more flexibility in your use cases for indoor high-density designs. Definitely use external antennas where you need to. The Hubble Exeltex team have a session tomorrow night, so you can look at their antennas a bit more. And don't put all your trust in design tools. AI can't fix all of the bad placements and designs that we have today. So with that, thank you so much, and have a good conference.